So let's take a look at this one here. And so this is an RC circuit again, but it's an RC parallel circuit. So, there are some fairly significant changes. The one thing that you notice, I don't have a triangle for voltage because, it's the voltages are going to be in phase because it's parallel. But notice that I have a triangle for current because current is going to be out of phase. And notice that I've drawn it this way versus this way. And the reason that I draw it this way is just to illustrate that we know that in a capacitive circuit, ICE, that current is going to be leading. So, we think of this as being, the amperage at the resistor on this axis, right? Because voltage and current are in phase. So I draw it this way, my amperage of the resistor, my amperage capacitor, because I know that in a capacitive circuit, if I was to draw the phasor, I know that, that current is going to be ahead, right? So if this is my R and this is my amperage capacitive, it's going to be leading in the circuit. So that's why I draw it that way. But in reality, it really makes no difference in this type of a circuit here anyway. So I thought maybe that somebody would have a question about that. So, and then of course, this would be my IT or my IRMS. If we're, to say that we're using my ERMS, I could say that's my IRMS. I just call it IT in there. So the first thing I want to do is I want to find what my IT in the circuit is. And, I know that I have a certain amount of voltage. I can't, I don't know what this value is yet. And once I know this value, then I can get this value. So I can't really get that yet. So I said that's the first thing we do, but we're not. First thing we're going to do is find out my amperage at the resistor, my amperage at the capacitor, because I know what my voltages are going to be because it's parallel. And I'm telling you that the voltage there is going to be 240. So now we can find my amperage at the resistor. So my amperage at the resistor equals my voltage at the resistor divided by my resistive value. So 240 divided by 30, nice even number. So I've got 8 amps. So I'll put that in there. And I'm going to put it over here too, 8 amps. And then I can find out what my amperage at the capacitor is my voltage of the capacitor divided by my capacitive reactance, because I already have it in there, which is 20. 240 divided by 20 is 12 amps. So the total value of voltage in a reactive and a resistive capacitive circuit is not the sum of the individual values of current flowing through the circuit. It is the vector sum of that. So to find my total value, I would have to use the Pythagorean in order to determine that. So I've got 12 amps here. So I'm going to say that my IT is equal to my IR squared plus my IC squared. 8 squared plus 12 squared. And I'll give you a second to punch that in. So you get the same answer as me, I hope. You betcha, 14.4. 14.42 amps. Okay, now now we can find some of other values. Now we can find our impedance. So we can do a couple different ways. We can go, the easy way. We know our ET or ERMS, and over my IT. So we can do it this way: 240 divided by 14.42. And if we do that, we get 16.64 ohms. Or if you prefer, you can do your impedance using, this 1 over R plus 1 over X, XC, and you get the same value. Okay, so we've got our impedance. This is the easiest way to do it, so because we got these two values here. So we have our impedance, and now we can find, let's see, let's find our true power. Let's find our true power and our reactive power, and then get our apparent power. So I'll give you a minute to get those values in.